Alright everybody, welcome to our video on 11.6, or to be specific about the topic, areas of regular polygons. These shapes are going to have problems that are going to be a little complex at times. I say that because they're going to be pulling in some material from the past that we've seen. Sometimes it's going to use a little bit of Pythagorean theorem. Sometimes you're going to see a little bit of trigonometry. And what you're going to have to do is you are going to have to use trigonometry to find some of these missing lengths that we need in these problems. If you don't remember how to do trigonometry, that's sine, cosine, tangents, SOHCAHTOA, that kind of thing, you may want to go back and watch that video. I do have a video that I made earlier, and you can go and take a look at that. So, let's begin with this. Starting by reviewing what a regular polygon is. A regular polygon is a polygon with congruent sides and angles. So, if you look at the figure that we have right there, what we can see is we have a circle, we have a regular pentagon inside. That is an inscribed polygon, a term that we used in our last chapter. So, what we have here now is we have to identify these different parts in this figure. Well, speaking from the circle standpoint, we can see that F here is the center. One of the radii of this circle, we could say that we have FA, that's a radius, going from the center to a point on the circle. So we could say FA is a radius. We could also say that FB is a radius. Now, here, the next one we have is a new term called the apothem. And what an apothem is it is a line segment starting from the center of the shape, which in this case the center of the pentagon is also the center of the circle. And what it is it's a segment starting there and going straight down to the middle of one of the sides of the shape. There is more than one apothem in a shape. That's one of them, but let me draw another one in. Here I am starting at the center, and I'm going straight down to the middle of line AE. That is also an apothem. Those green segments are apothems. And lastly, central angle, also something that we learned about recently. If we look, if we start at B, go through F, and finish up going through A, angle BFA is a central angle. Something important to know about central angles in these regular polygons is that if we make a line going from the center to each of the vertices of the shape, we're going to make a certain number of central angles that are all going to be the same size. And the way that we're going to find out how big they are is we just do 360 divided by the number of sides we have. And that's how big each of these angles are going to be. So let's think about then how we could use some of this information to find the area of a regular polygon. One really good way to do it would be to start at the center. And you'll notice that if I do this, I make a triangle. And if I connect to the other vertices as well, I have made 5 triangles that are the same size. It's 5 triangles because this shape itself has 5 sides. So we form 5 triangles, and they're all the same size because this is a regular polygon. So what I'd like to do then is zoom in on one of these triangles. What we can do, what we have the ability to do is
we can always figure out what this angle is going to be if we know how many sides the triangle has. Or, yeah, if we know, sorry, not the triangle, but the polygon that we're looking at. This was a 5-sided one, so we know that this angle is going to be 360 divided by 5, because there are 5 sides. What we can do is split that down the middle. What I want you to notice is that when we do split that down the middle, I'll do it in the main picture too, we're creating an apothem. It is also the height of one of this triangle. So if we can figure out this length, and if we can figure out the apothem length, we can do 1/2 base times height to find the area of the triangle. And since this shape had 5 of them, that means that we are going to multiply whatever the area of this triangle is by 5, and then we'll have the area of the pentagon. If you're looking for a formula to find the area, there is one that we can use that works out basically every single time when we're trying to do this. It's sort of a shortcut for what we have up there. If you understand what we just talked about up there, feel free to use that. It's a really good explanation for why this formula works, connecting to standard 2. But the formula would be that the area is 1/2 of the apothem times the perimeter. Remember that the apothem is kind of like the height of those triangles, and the perimeter is going to be all of the bases of those triangles added up together. It would be like if you lined up the triangles all in a row and just considered the bases as one long structure. So 1/2 of the apothem times the perimeter of the shape is a good formula that you can use. All right. I think I'm going to stop it here for this video, just to you got an introduction to the idea of the regular polygons and how to find the areas. Coming up in the next video, we're going to go into the examples that you see further on in this sheet. Thanks for watching this one. See you in the next one.